Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. The Honorable Miss Mutmainna MPD is our lecturer. Okay, we are from group 7. We will talk about the validity and reliability. Before we talk our discussion today, let us introduce ourselves. Okay, my name is Fitra Taqwa, and then the member of my group that are Fitri, Sari, and Inton. The first material will be explained by me. The first material, the title is The Importance of Valid Instrumentation. Researchers use a number of procedures to ensure that the inferences they draw based on the data they collect are valid and reliable. So the draw must based on the data they collect. Validity that refers to first that appropriateness, second meaningfulness, the third correctness, and the last usefulness on the inferences researchers makes. And what is reliability? Reliability refers to the consistency of the scores or answers from one administration of an instrument to another, and from one set of items to another. And the next is validity. Validity has defined as referring to the appropriateness, correctness, meaningfulness, and usefulness of the specific inferences researchers make based on the data they collect. And so we can conclude here the validation, that is the process of collecting and analyzing evidence to support such inferences. A researcher here must still give attention to the way in which they intend to interpret the information. The first, that is an appropriate inference, second, a meaningful inference, and the last, a useful inference. So here we have three kinds of evidences. The first evidence, that is content-related evidence of validity, and the second, criterion-related evidence of validity, and the third, that is construct-related evidence of validity. The first kind of evidence, that is content-related evidence. So here, the researchers plans to give students a math test containing about 15 such problems. The performance of students on this test is important. Only the degree that it provides evidence to their ability to solve this kind of problems. Hence, performance of the instrument, in this case, the math test, will provide valid evidence of the mathematics ability of this student. And the second evidence, that is criterion-related evidence. So here, criterion, that is to obtain criterion-related evidence of validity. Researchers usually compare performance on one instrument, the one being validated, with performance on some other independent criterion. And the last, that is construct-related evidence. Construct-related evidence of validity is the broadest of the three categories of evidence for validity that we are considering. There is no single piece of evidence that satisfies contract-related validity. Rather, researchers attempt more and the more varied the better. That will allow them to make warranted inferences to assert, for example, that the score obtained from administering a self-esteem inventory permit accurate inference about the degree of subsystem that people who receive the score possess. Okay, maybe just this for me. The next material will be explained by my friend.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fitra Sari. Okay, now I will continue our presentation. Okay, reliability. Reliability is the degree to which a test consistently measures whatever it measures. Reliability, it is the consistency of the scores obtained. It means how consistent they are for each individual from one administration of an instrument to another and from one set of items to another. And for example, a test designed to measure typing ability. If the test is reliable, we would expect a student who receives a high score the first time he takes the test to receive a high score the next time he takes the test. The scores would probably not be identical, but they should be close. And then the next is errors of measurements. Errors of measurements, it is the difference between what a test score indicates and a student's actual knowledge and abilities, or errors that are introduced when collecting and calculating data-based reports, figures, and statistics related to schools and students. Because errors of measurement are always present to some degree, researchers expect some variation in test scores or in answer or ratings, for example. When an instrument is administered to the same group more than once, when two different forms of an instrument are used, or even from one part of an instrument to another. Reliability estimates provide researchers with an idea of how much variation to expect. Such estimates are usually expressed as another application of the correlation coefficient known as a reliability coefficient. There are three best known ways to obtain a reliability coefficient. The first is test-retest method, and the second the equivalent forms method, and the last is the internal consistency method. And the first test-retest method. A test-retest method reliability is the degree to which scores are consistent over time. It indicates score variation that occurs from testing session to testing session as a result of errors of measurement. Test-retest method, it is same test but different times. And test-retest method only works if phenomenon is unchanging. For example, administering the same questionnaire at two different times. And the second is equivalent forms method. When the equivalent forms method is used, two different but equivalent, that also called alternate or parallel forms of an instrument are administered to the same group of individuals during the same time period. Although the questions are different, they should sample the same content and they should be constructed separately from each other. A reliability coefficient is then calculated between the two sets of scores obtained. A high coefficient would indicate strong evidence of reliability that the two forms are measuring the same thing. And then it is possible to combine the test-retest and equivalent forms methods by giving two different forms of the same test with a time interval between the two administrations. Okay, I think that's all from me. Now we go to the next presenter, that is Inton. For Inton, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. My name is Inton from PBI 2. Now, I will continue the material. So, the first I will explain about internal consistency method. The method mentioned so far all require two administration or testing session. There are several internal consistency methods of estimating reliability. However, that require only a single administration of an instrument. So the first about spilled half procedure. The spilled half procedure involves scoring to half, usually odd item versus even item, of a test separately for each person and then calculating a correlation coefficient for the two set of score. The coefficient indicates the degree to which the two halves of the test provide the same result and hence describe the internal consistency of the test. The reliability coefficient is calculated using what is known as the Spearman-Brown prophecy formula. Simple version of this formula is as follows. Reliability of score on total test 2 times reliability for half test and 1 plus reliability for half test. This if we obtain a correlation coefficient of 56 by comparing one half of the test item to the other half. The reliability of score for the total test would be reliability of score on total test 2 times 56 and 1 plus 56 is 1.12 and 1.56 and the score 72. This illustrates an important characteristic of reliability. The reliability of a test or any instrument can generally be increased by the addition of more items, provided they are similar to the original ones. Okay, next about Cadder-Richardson approach. Here, use the formula KR20 and KR21. The latter formula require only 3 pieces of information: the number of items on the test, the mean, and the standard deviation. However, that formula KR21 can be used only if it can be assumed that the items are of equal difficulty. A frequently used version of the KR21 formula is the following. KR21 reliability coefficient, K and K mean 1 in parentheses, 1 mean M in parentheses, K mean M and K in parentheses SD range of 2, where K5 number of items on the test and 5 mean of the set of test scores and SD5 standard deviation of the set of test score. Although this formula may look somewhat intimidating, its use is actually quite simple. Next, about alpha coefficient. Another check on the internal consistency of an instrument is to calculate an alpha coefficient, frankly called Cronbach alpha after the man who developed it. This coefficient is a general form of the KR20 formula to be used in calculating the reliability of items that are not scored right versus wrong as in some essay tests where more than one answer is possible. Next, next I will explain about the standard error of measurement. The standard error measurement is an index that shows the extent to which a measurement would vary under changed circumstances. For example, the amount of measurement error, because there are many ways in which circumstance can vary. There are many possible standard error for given score. For example, the standard error will be smaller if it includes only error due to different content, internal consistency, or equivalence from reliability. Then if it also includes error due to the passage of time, retest reliability. You can see the picture. This a person scoring 110 can expect to have a score between 100 and 120 1 year later. 5 years later, the score can be expected to be between 94 and 126. Okay, next I will explain about scoring agreement. Here, researchers who use such instruments are obligated to investigate and report the degree of scoring agreement. Such agreement is enhanced by training the observers and by increasing the number of observation periods. Instruments differ in the amount of training required for their use. In general, observation technique require considerable training for optimum use. Such training usually consists of explaining and discussing the procedure involved, followed by trainees using the instrument as they observe video or live situation. All trainees observe the same behavior and then discuss any difference in scoring. This process, or some variation thereon, is repeated until independent observers reach an acceptable level of agreement. What is desired is a correlation of at least 90 among score, or agreement of at least 80%. Usually, even after such training, 8 to 12 observation periods are required to get evidence of adequate reliability over time. Okay, the last I will explain about validity and reliability in qualitative research. Some take the position that validity and reliability, as we have discussed them, are either irrelevant or not suited to their research effort because they are attempting to describe a specific situation or even as viewed by a particular individual. They emphasize instead the honesty, believability, expertise, and integrity of the researcher. We maintain that all researchers should ensure that only inferences they draw that are based on data obtained through the use of an instrument are appropriate, credible, and backed up by evidence of the sort we have described in this chapter. I think that's all for me. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.